Let's talk about frequency and power dissipation in a capacitor. Now the capacitive reactance decreases as the frequency increases. I've got a little circuit here. I've got a 100 ohm resistor in series with a 10 microfarad capacitor, and I'm feeding that with 5 volts at 100 hertz. So we want to determine the amperage, the wattage, and the power factor. So we start with our formula for capacitive reactance, and we plug in these values, and that comes out to 159. Now to find this angle here, we just take the arctangent of the capacitive reactance divided by our resistance, or 100 ohms, and that comes out to 57.3 degrees right there. Now to find our impedance, we can just use Pythagorean's theorem. We take the capacitive reactance squared plus the resistance squared, and you take the square root of that, and that comes out to 187 ohms. Or we can just take the sine of this angle and divide that into our capacitive reactance, and that comes out to, when I did it here, it came out to 189 ohms, fairly close. To find our current, we just take the voltage and we divide that by our impedance, and so that comes out to 0.026 amps. Power. To find our power, it's just the cosine of the angle times the current times the voltage. So if we multiply that out, it's 0.07 watts. And the power factor is just the cosine of this angle. So that's going to be 0.54. Now, I'm going to take this same circuit and I'm going to supply it with 1,000 hertz at 5 volts and see what happens. So same thing, we do the capacitive reactance, we calculate that out, it's 15.9. We find our angle, and it's going to be 9 degrees. We find our impedance, which is going to be 101 ohms. We find our current, which is going to be 0.049. And so we find our wattage, or our power, and that's going to be 0.24 watts. And we to find our power factor, it's the cosine of this angle here, and it's 0.98 for our power factor. So that's the math. We'll see if it actually works on a practical circuit here. So I've got, this is a 10 microfarad capacitor. This is good for AC. That's why I'm using this one. It's MFD, but that's microfarad. Normally we see it as with that U on there instead of the M, but this is a microfarad. That's a 100 ohm resistor. I'll put this on AC, turn my generator on. I got 5 volts on that, and let's see what we have for our power. Can we see the 0.025 amps at 5 volts, and what did we think that was going to be? 0.026. Well, we're fairly close. Now I'm going to take the frequency and turn the frequency up to 1,000 hertz, and there we go, that's 1,000 hertz. Now I have to adjust the voltage up to 5 volts. There we go, that's close. And our current is going to be 0.044 amps. And what did we calculate that at? 0.049 amps. Well, that's fairly close. This is probably 10% capacitor and 5% on the resistor. So the math works. And if we can see all those numbers there we go, 0.045 at 5 volts. So that works. That's the power, frequency and power dissipation in a capacitor. Thank you.